Hi kiddos, so in this videos I will explain like basic concepts for my thesis in really a DIY fashion. So today I will speak about the difference between hierarchy and non-hierarchy on the basis of the structure. So what's the structure of a hierarchy, what's the structure of a non-hierarchy? If you think about a hierarchy, you think about like a pyramidal structure. So for example like this. That's like one of the classical views when you think about hierarchy. So we can distinguish two properties here. First is anti-symmetry. So anti-symmetry. It means like an arrow always goes from one direction, so it's from the top to the bottom. So like an arrow going this way, not the other way around. An arrow going this way, not the other way around. It means there can be like a power over relationship, that there's like influence going from one element to another element, but no influence going back. If there's like no anti-symmetry, there can be cycles. So there can be like an arrow going back, which means there's like a cycle. Thus, one of the properties of a non-hierarchical system is that there are cycles. For example, like this. The second property, of a hierarchy is that, like you see, these arrows split, almost split, so they're like one element at the top and then more and more elements as you go down. Thus, concretely what it means, like this, like in an element there can only have one arrow, while there in general there are several arrows starting from it, which means like you can only be influenced by one element, so you're kind of determined by it, while one element can like influence a lot of elements, so that its influence can spread. It's the second property. What means in a non-hierarchical systems you can have like multiple influences. For example, this element can be influenced by multiple ones, which is often part of a cycle. You can have like multiple cycles like this, so that this element is also influenced by another element. For example, this element can also be part of a cycle. We have like these overlapping cycles. You have like here, for example, you can have a cycle. You can have a cycle like here. Thus we have like overlapping cycles where every element is like influencing another element and at the same time being influenced by several other elements. Thus you can't really determine like one cause, while in a hierarchy we clearly have like one element that causes everything. And you can prove that because of those two elements, so the anti-symmetry, and every element only being influenced by one other element, it's caused that there's like only one element at the top. Shortly, the idea of the proof is that when you go up you have lesser and lesser elements, because like lesser or equal, because there can't be more elements, because then they would influence several elements. So as you go up you have like lesser and lesser elements, so that at the top you need to have only one element, because also if there would be two elements they would both influence some elements below. Assuming that of course it's like a connected network, you could have of course two completely separated networks. So what we also have in a hierarchy is clusters. They're like, because these influences always, there are only one influences, it's in clusters, like, while if there would be multiple influences, for example, this element could be influence this element, this influence could influence this element, and then these clusters disappear. So here you see you don't really have clusters anymore. What do we see here? These intertwined cycles. We see actually, if we look at in the form of cause, that the system is self-caused. That it's like causing itself because of these cycles. You influence, you kind of cause yourself. You first start, you cause one element, and that element causes another element, and that element causes back to you. So there's like self-causation, self-creation, which is called in a fancy name autopoiesis. It means you can be self-maintained, can be self-sufficient, and it's like one of the properties in living systems.